I'm going to focus on the areas of chapter 4 that I know that you're going to see on the final exam, okay? The first thing that we did in chapter 4 is we dealt with proportions. And in the first set of exercises, solve each proportion, okay? So what we're doing here is this. In problem number 1 here, you've got n over 6 equals to 12 over 9, okay? Now, the property proportions that we're going to use here sometimes is referred to as the means, extremes, properties of proportions, okay? And so the means, extremes. Whenever you're looking at a proportion, remember this. The top left-hand, the bottom right-hand corner values are referred to as the means. The bottom left, top right-hand corner are referred to as the extremes. The main thing I want you to know here is that to solve this, y'all know how to cross multiply, right? And every one of you should have paper out. Every one of you should have paper out. So what we're going to end up doing here is this. 9n is equal to 12 times 6. Okay? All right, so what we're doing here is this. 9n, 12 times 6. Can anybody venture to tell me what 12 times 6 is? 72. Dividing by 9. What's n going to be equal to now? 8? Okay, that's right, 8. Okay? Now, we're going to do another one, and I'm going to try to do this with you guys, all right? We're going to separate into our groups again. I'm going to put another problem here on the board, and we're going to try to get this done, okay? So we've got, let's see, we're going to do problem number 2 here, which is going to be 13 over n equal 39 over 20. Okay, so when solving this one, most of y'all I think got this right. Cross multiply, and you've got 39 times n is equal to 13 times 27. What was 13 times 27? 351, okay? So from here, you divide both sides by 39, and when you do the division, you find this is your answer, okay? All right, so this was chapter 4.1, these problems that we just covered here with proportions. We're going to move on to 4.2. Now, we were dealing with word problems in 4.2, and I want to do a problem, number 9 as an example. Okay, number 9 says this. What is 55% of 60? Okay? Now, there were 2 methods that we had used to solve a problem like this. There was the proportion method, and then there was the equation method. I think I'm going to stick with the equation method for this, for the final exam, for where I want you to focus your attention on, just one method instead of 2. I think most of you are somewhat familiar with how to translate a sentence like this into a math sentence. So whenever you see the word what, think a variable. Think like, let's say generally speaking, like think the number, the variable n for number, okay? Is, y'all know, always means equals, okay? 55%. Rewrite that as a decimal by understanding that to be 0.55, right? Take the decimal point, move to the left 2 places. Of always means multiplication, doesn't it? Okay? And then 60. So this one should be very straightforward. 0.55 times 60. Take a moment. I want to see if y'all can tell me what 0.55 times 60 is. So we have the answer here is 33. All right? 33 is 55% of 60. Now let's do one more as a group here, okay? This one is going to be organized a little differently. Number 10. 28 is 70% of what number? The first thing I'm going to want to see from you guys is the math equation, the math sentence, as we would say, that you should translate this into, okay? Here we go. What you're going to do here is this. 28 equals 0.70 times n, okay? That's how you translate that into a math sentence. To solve for n, you're going to divide both sides by 0.7. So you're looking at this. N equals to 28 divided by 0.7. And what did y'all get that to mean? What's 20? 40. Okay, everybody agrees? Okay, 40 is your answer. All right, that's what N is equal to. All right. All right, the next thing that we're going to review here is in section 4.4. All right, 4.4. We're reviewing the concepts mean, median, mode, and range, right? So mean, median, mode, and range. Okay? Okay. Smart board was a little more cooperative right now. Yes. All right, so our first problem is going to be this. Number 25. Here is your data set. You've got this number, these set of numbers here. 6, 8, 8, 11, and 7. Now, first of all, what do we mean by mean? Isn't that the average? 6 plus 8 plus 8 plus 11 plus 7 divided by how many terms, right? 5. Perhaps what I should do is back up for a moment and say this. I think as a habit, what you should do when you see these data sets is you can actually rewrite them in numerical order. 6, 7, 8, 8, and 11. Okay? Regardless, the sum, the average doing this is not going to change. But let's see if we can calculate the mean here. So yeah, the numerator adds up to 40 divided by 5. The mean is going to be 8. Now, what is the median? What do we mean by the median? The middle number, isn't it? And so the median is going to be right here. The median is 8. So the mean is going to be the one that takes the most math to calculate. What about the mode? The mode is, again, 8. What is the mode? The number that occurs the most. Okay, so the middle number is 8. The one that occurs the most is 8. The mean is 8. Everything's 8. I don't know. Let's see what the range is. So the range is different. What is the range? The difference between what two numbers? The biggest and the smallest. 11 minus 6, right? So you'll say 11 minus 6, and that's going to be 5. All right? Got it? Okay? That's what's happening here. Okay, so problem number 26, the data set 5, 7, 10, 13, 21, and 3. Okay, I want you guys to order this data set first of all from least to greatest. Then I want you to find the mean, median, the mode, and the range. All right. Okay, so once you add those terms of the numerator up, divide by 6. 9.8 is your answer. And, you know, let's go ahead to do the mean, median, the median, mode, and the range. You definitely got to make sure that you order these from least to greatest. What's the first term? 3. 5. 7. 10. Okay, so what's the median? How are you going to find the median when you don't have an exact middle term?
Are you going to?
Yeah. So what is 10 plus 13 is 23. What's 23 divided by 2? 23 divided by 2 is what? 11.5, right? So you're going to say 10 plus 13, divide this thing by 2, 11.5, okay? Okay, what about the mode? Is there a mode? There's no mode. Right, none. Okay. What about the range?
18.
21 minus 3, right? 18. Got it. Okay, we're going to begin the chapter 5 review now. And pages 266 to 270. And we worked a lot with lines here, equations of lines, slopes, how to graph them, things of that nature. The first thing that we did is we determined in section 5.1, we talked about relations versus functions. Okay? Now, there's various ways that we can approach this particular concept. And what we did, one of the primary things we did in section 5.1 is given a set of coordinates here, 7, 12, 6, 9, 7, 8, and 4, 11. We have to determine whether or not these points collectively are referencing a function or is it simply a relation. Remember this, every function is a relation, right? Because it states a relationship between two numbers, all right, two data sets. Not every relation is a function though, right? Within the context of all number pairings that could take place that we could call relations, a subset of those, given some unique circumstances, some of those relationships would given the further definition of being called a function. So how can we tell whether or not this is a function or not? What do we look for? We look at remember the domain means all the first elements of these ordered pairs, the range are the second elements, right? So regarding the domain, I'll tell you what let's do. Let's describe the domain. Let's describe the domain. Then let's describe the range. And remember here, when you're describing domains and ranges, you have to keep the numbers in order. So what are the domains? What are the elements of the domain? 7, 6, 7, and 4 in there. So if I were to order these things, I would say 4, 6, and then just write 7 once. A lot of you guys on your test, I remember this in chapter 5, when y'all saw an element of a domain or range listed twice, you listed it twice in your description. You don't do that. You just list it once. But yeah, since the number 7 is listed twice, we can already tell this particular relationship is not a function. And that's what I want you to put here. This is not a function. It is a relation, but it is not a function. Now let's describe the range. 8, 9, 11, and 12. Okay, right. Is everybody clear on that? That's good. Okay. 8, 9, 11, and 12. Now, the next one we're going to do, problem number 2. Okay, this one, 5, 5, 10, 7, 7, 15, 4, 9. Okay, you ready? Y'all go ahead and do that. To further explain, and yes, this is going to be a function. The answer here is yes. Just write the word function. Describing the domain, remember keep everything in order. 4, 5, 7, and 10, right? Describe for me the elements of the range again? 5,
7, 9,
15.
15.
Okay, now, y'all remember when we did these ovals? I'll put a D here and an R here, right? And I put the elements of the domain, 4, 5, 7, 10. Y'all paying attention here? Shh, be quiet. The range is going to be 5, 7, 9, and 15. Well, let's look at how these numbers are paired together and draw some arrows here. What number is 5 of the domain paired with in the range? Talk to me. What number is 5 in the domain paired with in the range? It's paired with 5, isn't it? So I'm going to draw an arrow here. What 10 is paired with what? 7. Okay, 10 is paired with 7. Okay, what about 7? What is it paired? 15, isn't it? Okay, what about 4? 4 is paired with 9. Now, when you're looking at these arrows, going from the domain to the range, if you don't see an arrow, more than one arrow emanating from any one of these numbers here, it's a function. Okay? That would be another classification. But y'all understood this. That's the main thing I think for this particular scenario for the exam that I think I'm going to need you to know. I'm not going to make you do this. If you do this, impress me, I might give you some extra credit on that. Woo. Okay, in section 5.2, we were talking about slope. Let me throw some things out rapid fire at you that you need to know for this, okay? First of all, the slope, designated by the letter M, is, we refer to it as the change in Y over the change in X. Otherwise known as what? Rise over the run, correct? Now, there'll be some problems on your final exam. One of them might look like number 9. If you're told you have a particular line where the rise, you have a rise of 4 and a run of 8. First of all, what does that mean? That means, like, if you look at the Cartesian coordinate plane here, look over here at the graph. It's every 4 units you go up, you're going to run it 5 or 8 units to the right, okay? It's going to do that, all right? All right, so let's continue on here. So if you've got a situation where the rise over the run, what this means is, this would be an example of a line that would have this slope. Not the only line that would be, but let's say if we start at the origin, if we go up 5 or 4 units, 1, 2, 3, 4, run to the right 8 units, 1, 2, 3, 4, 5, 6, 7, 8, right? Then passing through the origin, this would be an example of what a line would look like that would have that rise over the run. What is the slope? The slope, remember, we defined it as rise over run. So what does that mean? 4 over 8, which reduces to what number? 1/2. Correct. Okay? Good. Remember that? So, on number 11, you've got a rise of 12. Rise of 12. And you've got, okay, so look, problem 11, I want y'all to do this. Rise of 12, run of 18. Go. Okay, so rise over run. 12 over 18. Look, this is what you should do. Got it? You see how to simplify this? What you should do is, if you break down, if you're not sure how to break this down to its simplest form, take the numerator and denominator and break that down as the product of prime factors. And this becomes 2 times 3, does it not? What about 18? 2 times 3 times 3, right? What common factors cancel? I see a 3 gone. The 2's are gone. What's left? 2/3. That's how we do it, all right? Okay, now watch this. This time, you've got to find the slope given 2 specific points on the line. Calvin? 2 specific points. 2, 5. This is the address, the coordinates of one point. 4, 1 is the coordinates of the other one.
So,
use your formula for slope to calculate the slope here. What is that?
oh, it's 4 over 2. Negative 4 over 2. See, I got it right.
When y'all look at these, it can help you. You've got these 2 points. Go ahead and write over each one of the coordinates. X sub 1, Y sub 1. X sub 2, Y sub 2. You see that? Plug the elements into the equation for slope. You got it? All right. So again, try to go. All right. So we're off to section 5.4 now. All right. 5.4. What we're doing here is we're writing equations in slope-intercept form. Now remember, what is slope-intercept form? Y equal mx plus b, right? You know m is the slope. B is the y-intercept, correct? Okay. So on number 37, we are told that you've got a line with a slope of 2 and the y-intercept of a 1. Okay? Okay? Now what you got to do is write the equation and slope-intercept formula. If this is what you're looking at, this is easy. The slope you're told is 2, right? What is b? The y-intercept. What's b going to be equal to here? 1. So if this is the slope-intercept form of a line, you just have to plug the slope and the y-intercept in there. This becomes. Oh, good. Good job. Good job. Okay. Okay. Yes, that was very straightforward. Okay. Now, let's have a little bit more fun here with this. Now that you see that, we're going to do another problem that's going to employ what you just showed me your ability to do, to draw a slope given 2 points on a line. Okay? And you're going to write an equation in slope-intercept form given this situation here, problem 41. The line contains these 2 points right here. 2, hang on, 2, -1, and a -3, -1, okay? So keep in mind what you've got to do here. You're going to have to use your formula for slope, and we've got to figure out what the y-intercept is going to be. So it's the way that we had done this. All right, this was a little bit more straightforward than what I thought. I was hoping to get one. I'm going to give you another one here, but you're good. I'm glad to see this. Yeah, you remember the slope. If the slope is 0, you've got a horizontal line here. So we calculate the slope, a -1 minus a -1. Keep up with two negatives. A -3 minus 2 gives you 0 over a -5, correct? So yeah, the slope is 0. So if the line is horizontal, do you remember how we would format the answer? What is it? If any line that's horizontal, remember this. If it's horizontal, it's always going to be, right, y equals 2. Remember, a horizontal line is going to pass through the y-axis somewhere, let's say right here, and it's going to run parallel to the x-axis, right? So you would say y equals to what number? What do you think? 2, -1, -3, -1. What point do they have in common? You see that? It's going to be a, okay? All right. This is going to end up being the equation of this line here. Y equals to a -1. All right. I thought I was giving you a different one. We're going to do this one here. All right. Number 40. We're going to go to number 42. One more in this section here. Yeah, 42. This time you're given the line containing these 2 points, -6, 0, 0, -2. Okay? Okay, so when we're calculating slope here, all right, most of y'all were seeing this. Some of y'all were getting your numbers mixed up. All right, go ahead and put these subscripts underneath your x's and your y's if you need to help you organize your formula here. Okay? Remember your formula. There's no easy way around it. You just got to know this. Okay, so you've got a -2 minus 0. Then you've got a 0 minus a -6. Keep up with your negatives here, right? So this is going to become a -2 over a +6, which reduces to a -1/3. Now, some of y'all, I know this group over here, accurately recognize that this point, 0, -2, was the y-intercept, okay? I think Gianna and you guys, y'all identified the -2, and maybe you guys did the same thing. If you didn't know what the y-intercept was, it wasn't that straightforward. Remember one of the methods that we had used to derive that? Let's take let's take one of these ordered pairs here, -6, 0. You've got the slope. And let's say we want to find out what is the value of that intercept. If we substitute what we know the slope to be here, then put one of these coordinates, one of these ordered pairs in here, substitute the x and the y in here. We can then calculate whatever the intercept is going to be. So if y is 0, the slope is a -1/3, x is a -6, right? we can solve for b here. Negative times a negative is a positive. What's a negative 1? What's a negative 1/3 times a negative 6? Can y'all tell me? Which is 2, isn't it? So you're looking at 0 is equal to 2 plus b, and of course now to solve for b, what do we do? Subtract 2 from both sides, yeah. So now what do we find b to be?
Negative 2.
Yeah. So that's what you need to be able to do. And hang on to it, because that's going to carry over the goal line. This is going to be the one. This is going to be the method that will help you negotiate your way to winning these problems. Okay. Next section we need to do. How to write an equation in standard form. Now remember that. What is standard form? Can y'all tell me?
Standard.
AX. Yes. Yeah, y'all gonna do great. You're gonna do great on this exam, I can tell. Okay, so problem 57. Y plus 9 equals to 4x minus 8. Remember, to get this thing in standard form, we've got to get your variable terms, your x and y's, on the same side of the equation. Remember that when we're looking at this, A, B, and C, they must be integers, right? A, B, and C must be integers. No fractions. No decimals. A must be positive. Yeah, okay? It's okay if B and C are negative, but that A cannot be. So let's subtract 4x from both sides. So I'm going to go through the process. Yeah, that's a 4. Okay, negative 4x plus y plus 9 equals to a negative 8. Now let's get the 9. Subtract 9 from both sides, right? Negative 4x plus y equals negative 8 minus, what's a negative 8 minus 9?
Negative 1. I mean, positive. Oh,
Positive, negative. Positive, negative.
Positive.
I hear positive. Okay, listen.
It's
When you
negative.
combine two negatives, you get a bigger. This is not multiplication.
It's positive.
Don't mix up the rules for multiplication with addition and subtraction. Listen, if you're here on your number line, here's your origin. Listen. Bring it down. Bring it down. Negative 8 minus 9. What is that telling me to do? Go further to the left, doesn't it? So you're going to get a bigger negative or what? Right. So we've got a negative 4x plus y equals to a negative 17. Now, still got am I in standard form yet?
No.
What do I got to do? Multiply both sides by a negative 1. Okay, so that's going to change the sign of everything. Now is it standard?
Yes.
Okay, I'm going to ask you to do one more problem for me, okay? You're about to cross the finish line. Number 59. 59 says to do this. 59, y minus 13, 2x plus 4. On this last one here, 59, y minus 13 equals 2x plus 4. For the most part, y'all really nailed this, which was good, right? Pay attention. Okay, so we've got, once we subtract 2x, a negative 2x plus y, add 13 to both sides. Make sure that you keep up with what becomes negative, what becomes positive. Don't put some negative signs on terms that don't need it. And so we end up with a negative 2x plus y is equal to 17. Now we have to multiply everything by negative 1 here, don't we? The entire equation has got to be multiplied by negative 1 to make the coefficient of x a positive number. 2x, excuse me, minus y, negative 17. This is standard form. If I were to ask you to identify A, B, and C, you should tell me A is equal to 2, B is equal to negative 1. C is equal to, yeah, okay. All right, that's going to conclude our chapter 5 review. I do want you to officially tonight do that in your homework. You did chapter 4 last night, so you know what your homework tonight